This example asks us to graph two different functions. We have y equals negative 2x squared, which is meant to be more of a review, and then we have x equals 3y squared, which is new. So let's start with part A, y equals negative 2x squared. Remember that we start with our simple function, or our base function, y equals x squared. And that's something that ideally you have committed to memory, and it looks something like this. It's a very standard parabola. It goes through 1, 1, and then 2, 4. There we go. Negative 1, 1, and negative 2, 4. Okay, so something like this, right? And the idea is you start with this base function, and then you shift it and stretch it and reflect it to get the new functions. So what we have here is this negative takes this base function and reflects it about the x-axis. Okay, and then this 2 here stretches it by a factor of 2. So we have this, we're going to reflect it down, and we're going to stretch it by a factor of 2. Okay, so our vertex is still at 0, 0, and then we're going down, and then instead of 1, 1, negative 1, which would be here, we're now stretching it. So we're actually down one more point down here. Same thing at negative 1, instead of being at negative 1 right here, it's now stretched by a factor of 2, so we're multiplying all those values by 2. Now instead of 2, negative 4, we multiply that by 2, so we have 2, negative 8, way down here. And instead of negative 2, negative 4, we multiply that by 2, negative 2, negative 8, way down here. We could have also gotten that other point using this symmetry. Okay, and here we go. Connect these points into our parabola. It's kind of a skinny parabola. It's opening down instead of up, and it's stretched out. So just in general, y equals ax squared plus bx plus c. If a is greater than 0, so if that's positive, it opens up. Okay, and if a is less than 0, it opens down. Right, and we don't even have a bx plus c, we only have our a term. But luckily for this to work, all we really care about is the a term. So that's how that goes. Let's look at b. For b, we have a different situation. This one is going to open sideways. When we have y equals something, it opens up and down. But when we have x equals y squared, now it's opening to the left, to the right. In general, if the leading coefficient is positive, these sideways parabolas are going to open to the right. So if they're of the form x equals ay squared plus by plus c. So if a is greater than 0, it opens to the right. And if it's less than 0, it opens to the left. So a less than 0 opens left. Okay, so that's how that goes. So let's look at this example, x equals 3y squared. This is positive, so it opens right. And it's also stretched by 3. So that is a stretch. All right, so let's do it here. So we start at 0, 0. And you can think of a base function here to start with would look something like this. Right? It would just be the same thing as the one we had opening up, but now it opens to the right. So we go 0, 0, we go 1, 1, and then we go, let's see here, 4, 2. So that's a little different. You have to get your brain used to thinking sideways a little bit here. So that's 1, negative 1, and then down here we would have 4, negative 2. Okay, so this is our sideways parabola. This is with no stretching or anything. So this is y. Let's make that x equal y squared. It's hard to get out of thinking in terms of up and down functions. So it requires a little bit of mental gymnastics, whereas this one up here was y equals x squared. Okay, so let's do that. We're going to take this base function and we're going to stretch it by 3. So stretch by 3. No problem. We have our vertex here at 0, 0. Now instead of going, we go over 1, instead of being up 1, we are now up 3. So this is really stretched out. It's going to be pretty narrow. And negative at, when we go down to -1, we are over 3 again. And then what would be 4, 2, now we want to multiply that 4 by 3, so it would actually be 12. So we're way out here, 12, 2. So that would be 12, 2, because I multiplied this 4 by 3 to get it really stretched out, and we'd get the same point down here, off the grid there. This is 12, 2. This is 12, -2. All right, so this is really skinny. Stretching does a whole lot to these parabolas. Something like this. There we go. Stretched out, opening to the right. It's just a new way of thinking about parabolas as opening to the right and the left instead of up and down. They're still parabolas, but note that this is not a function. This would fail the vertical line test.